Alright, so we were able to figure out that by plugging in P of 0, we got C. Now, P of 1, A times 1 squared plus B times 1 plus C. Now, what's 1 squared? 1 times A is A. Now, what's B times 1? B and plus C. No, these are just outputs. That's what we're finding right now, is just outputs. So that's going to be A plus B plus C. Alright, so if we have P of 2, we're going to get A times 2 squared plus B times 2 plus C. What's 2 squared? 4. So we're going to get 4 times A plus 2B plus C. So we're going to get 4A plus 2B plus C. P of 3 is going to be equal to A times 3 squared plus B times 3 plus C. So what's 3 squared? 9A, 3B plus C. So I'm going to get 9A plus 3B plus C. And then P of 4 is going to be equal to A times 4 squared plus B times 4 plus C. So 16A plus 4B plus C. Anybody disagree with those values? Alright. If no one disagrees, that's just plugging and chugging with those numbers. So my first difference, I want these two values is going to give me my first difference. So I'm going to get A plus B plus C minus C. So what's going to happen when I subtract a C from here? What am I going to be left with? Yep, A plus B. Now, if I'm going to subtract these two, I could just kind of take a look at this. 4A minus A would be 3A. 2B minus B is just 1B. And C minus C is 0. So I get 3A plus B. Now I need these two guys. Yeah, 9 minus 4 is going to get me to 5A. 3 minus 2 plus B and C minus C. It's gone. Do you notice anything about the C values here in the first difference? We got rid of them, didn't we? In the first three, we got rid of them. And now here, 16 minus 9, 7A, 4B minus 3B. That's plus a B, and the C's are gone again. So the first difference, actually, we were able to eliminate the C's out of here. Now, the second difference, I need to subtract these two values. What's 3A minus A? 2A. What's B minus B? 0. So I'm left with the 2A. So I have 5A minus 3A. How many A's do I have left? So I have 2 A's. And then B minus B is 0. So it's left equal to 2A. Now I have 7 A's minus 5 A's. How many A's? So I have 2 A's left. And then B minus B is 0. Now does this reinforce the idea that for these values, that should be a 2 times A, that should be a 2 times A, and that should be 2 times A. And when we plugged in numbers, we ended up with the second difference is equal to 2A. So it ended up working out perfect. Exactly the way that we thought it would. So this is not proof, but it's more evidence that this idea is true. So when we use our numbers, it's just more evidence that it's true, not necessarily that it's proving that it's true. Because we used numbers. We proved that it's true for this function with the inputs 0, 1, 2, 3, 4. But if I took like 1,000, 1,001, 1,002, 1,003, 1,004, is it going to work? That's what we want to have done. Now, what you're going to do tonight for me is you are going to prove this is true for these values. So we got an squared plus bn plus c at the beginning, and then you're going to come up with a more convoluted type of thing from this. So we're going to take, just to give you a quick hint here, it's going to be a times n plus 1 squared plus b times n plus 1 plus c. And you have to expand this one and then this one. And then you're going to get, like I said, a big, long, convoluted term. And then we're going to subtract these. And you're going to find the first and second difference. And you're going to hope that this is equal to what? What should the second difference be equal to if we did it right? And it's true. 2A. So I want you guys to prove this tonight. So that's the only homework you have.